we're now recording, and the point of that is that for you guys, if you want to look back on this workshop later and you want to go through, or there's anything you might have missed, then you'll have that recording there for you. And we also want to have that as an opportunity for you to make it more interactive, so you feel like you can actually work along with the problems that we're doing, or the content. So thank you all for coming. I guess I should start by introducing myself. My name's Martin. I am one of the pass assistants that we have. I'm based on the Gold Coast, and my role is essentially to run the reporting and statistics side of pass, to see how we can improve the program and how we can make it a lot more beneficial for you as students. So I've been a pass leader for 5 years, and I've run these workshops for I think 2 or 3 years now. And this will be the first in a, I guess, 2-part series that we run, because I normally do a beginner one and then an intermediate one. So that'll be most likely in week 7. So keep your eye for that. But yeah, so the point of these workshops are to give you guys a bit of an insight into how Excel works, why it's so useful, and how you can actually apply it to your degrees. So I started this initially doing it as an Excel for Engineers project, where I was teaching engineers the Excel skills they needed for their thesis, or for a few of the courses they needed. But that's since shifted, and I've now made it more broad so that it's for scientists in general. So anyone doing STEM programs can really relate and take a benefit out of these, I hope. So we'll get started, I guess. So up on the screen there is our session agenda. So we have an hour here today, so there's only so much we can do within an hour, but I'm hoping that it'll be enough that it gives you guys a bit of a start into what you'd need for Excel, and how to actually start to play with data and to use it for different aspects of your university degrees. So I'll start by talking about its applications in STEM and why it's so good. And then I'll go through an actual Excel workbook. So again, because we only have an hour, there's not going to be much room for questions. And normally I like to make my sessions pretty interactive, and we can work through things together, but that's a little bit difficult given the short time span. So that's why we are recording it. So if you do have questions, do feel free to write it, and one of our moderators will pick it up, and then I might send out an email that answers them, like a frequently asked questions type thing. If not, my email will be on one of the slides at the end, so you can directly email me, but it will be a bit difficult to stop in between. So I'll run through each of the Excel tabs to start with, and then I'll explain what's in each and why they're so important and what you can do with them. Then I'll give you guys a bit of an introduction into basic Excel functions. So we'll look at adding things, we'll look at subtracting, division, multiplication, and then we have an example problem to work through. And in that problem, we also have a data presentation type of scenario, where I'm going to run through key aspects of data presenting in STEM subjects. So I'm not sure how many of you have been exposed to that yet in your degrees, but presenting graphs in a clear, concise, and effective manner is really important. And I'm going to show you a basic rundown on how to do that with Excel. So after that, I'll give you an additional example. If we have time, you can start it throughout this session, but I don't think we will. If not, you can feel free to do that in your own time. And then if you have any issues or any concerns with that, you can email me and I'll be happy to help you with that. And then we'll have a session summary and close. So that'll just sum up what we've covered in the session. And I'll reiterate why or how you can apply that through your degrees. And we might have a bit of a time for some general questions at the end if needed. So, not up to that yet. Okay, so what I'll do is I'll share my screen for now. And in doing so, I will show you an Excel workbook that I've got up. So at this point, you don't necessarily need to have one open. I'll just be doing that for you to see what's going on. So we won't actually go through anything at this point, but I just wanted you guys to be able to see. So my Excel might look slightly different from what you guys might have if you opened it. So you probably won't have this blue beam thing or these Q-tools here, but most of it should be the same. So I'll start assuming you have no knowledge of Excel, what it is. Excel is essentially a data manipulation tool. So we can use it to formulas, to have data, and to make it do things with that data. So it's really useful in a lot of statistics and presentations, and it's quite valuable in terms of STEM subjects because it allows us to synthesize big quantities of data into really easy to read and really easy to identify patterns. So the first tab is pretty standard for most Microsoft products. So you've got things like your fonts, your text, your justifications. You've got some things for rows and columns. Where it differs is that we've got a lot of different applications for our numbers. So Excel is very smart and it can differentiate between amounts of money, percentages, and it can even move decimals for you. So it's quite versatile in how you can apply it, and these are some of the more common tools that are used, which is why they're there. So we might go into that a bit later. On the second tab, our insert tab, this is where you'd probably start to see a bit more difference between Excel and a lot of the other Microsoft Suite programs. So here is something that you should become pretty familiar with. So it's your charts. You can make many different types of charts in Excel. You can make line charts, bar charts, column graphs, scatters. There is no real right or wrong chart, but you must always be aware with Excel that some data is easier to present with different types of charts, and that comes with experience and knowing about what your data is meant to do or how it's meant to be presented for you. So we'll go through a little bit of that today and highlight why that's so important. So page layout, this is pretty stock standard. This is just how you want to orient your page and your margins. So I won't go into that into too much depth. The only thing that might be useful is this. So this scale to fit, that's about scaling the size of your pages with their number of cells. So that's more reference for if you're printing things. So there's two ways you can actually apply formulas in Excel. So you can either use these formula tools here. So if you wanted to do, for example, math and addition, you can click here. You can search for, say, if I want to add something, you look for sum, you press it, and then it'll come up, and then you can type what you want to type here. I tend to find that's a little bit complicated. So typically, these are more if you don't know what you want to do. So if you don't know what the capabilities are of Excel, feel free to go and look through, and it's quite useful. You can normally hover over them and it tells you what the actual formula will do. So it's quite beneficial in that respect if you're not so familiar. But if you are familiar with Excel, then it becomes a bit more tedious to do it like that. So for example, if I use the sum query that I was talking about before, say I've got two numbers here, 2 and 3, and I wanted to add them together. So we all know 2 plus 3 is 5. I can put on any cell I want. Let's just say, pick that cell there. If I wanted to sum those numbers, you can do equal. So equal in Excel always denotes the starting of a formula. So whenever you have equals, you're telling Excel, I want to do something that's a formula. It doesn't take equals as a text string. So it's always done as a formula. So there's two ways we can add those numbers. So because we have a really low data set, so there's only 2 variables there, we can just do equals, and then we can click on that cell. And you see at the top here, it comes up with C2. So it says that that's the cell we've clicked. Then we can just do plus, click the D cell, D2, and then we press enter. And you see it sums it for us. So that's pretty basic. If we had a larger data set, then it might be easier to do a sum. So we can go equals sum, and then you put a bracket. So the bracket denotes us wanting to enter some variable. So here it's saying for sum, we can put number 1, number 2. So it's telling us what do we want to sum. Now, you can just highlight them like that. So it's a cell range, and it'll just automatically sum them for you. So those are a couple ways in which you can do that with Excel. So I'd recommend having a play around with that and looking at what works best for you, because there's so many ways to do the same thing in Excel. It's really not a one-size-fits-all thing, and there are a million different ways to do the same thing. It's just a matter of preference and what you really want to take out of it and what you are actually trying to do with your data. So on our next tab, we've got data. So this is a pretty cool one, but it's more, I guess, advanced in terms of what you do with Excel. So this is where you can start to look at data synthesizing. You can look at data analysis, and you can use it to make things like lists and drop-down menus and different things that relate to other pieces of data. So we probably won't get into this one today because it's a little bit more advanced in terms of what we're actually trying to achieve. But just be aware that it's really useful. So if you do end up using Excel a lot, this is probably something you'll come across. Review, that's typical for your Microsoft suite. So it's about protecting your sheets. It's about adding comments, spell checking, and so on. I won't go into that. Your view, so view is, again, mostly pretty similar. The only, I guess, additional thing here is you've got formula bar, which is that formula to see what we're adding in. But there is something I did want to bring up here because it's something that even a lot of people who are very familiar with Excel don't always know. It's this freeze panes option. So if we click on that, it says keep rows and columns visible while the rest of the worksheet scrolls based on the current selection. So this is pretty useful for a few reasons. If we have big data sets, I don't know if anyone has used it before or had to work with data like that. But if you've got a data set, say I put here title, this is my title, and then I put the number 3, and then I'm going to copy that 3 all the way down to the bottom. So say I've got a data set like that, and scroll down. Now you've lost your title here, and with data that spans, across a sheet, that can be really confusing. The freeze panes option is a really cool tool to avoid that. So what it can do is, I'll make it here, I'll say title 1, and I'll put it across. So here we've got 15 titles. So we might have a data set that talks about different things. So for example, I am currently doing my PhD on water quality. So I might have something here that has things like nutrients in the water, turbidity, dissolved oxygen, ammonia, and a range of different parameters across there. Now, if I'm obviously working with data down here, I can't see the title, so I don't know what each value would correspond to. So freeze panes allows me to highlight the cell below, press the button, press freeze panes, and then when I scroll down, it stays there. So no matter how far I scroll down, you can see on my left-hand side here, I'm at the 320th cell. It'll always keep that title. So that's one of the big things that, I guess, the quality of life aspects of it that I really like. So that's just one thing I wanted to make you guys aware of, is that freeze panes. The way it works is dependent on which one you press. So I'll unfreeze my panes at the moment. If we do freeze top row, it'll freeze this top row, the first cell, across the whole thing. If we freeze the first column, it'll freeze, obviously, the first, so everything that's in that first column will remain. If we, though, do the freeze panes here, it'll refer to whatever your mouse cell is on. So if my cell's on this one, so right now it's on H8, if I freeze panes here, everything that is below the H cell and to the right of the, or below the 8 and to the right of the H will be frozen. So now if I typed anything here or here, that is going to automatically be kept. So now if I go across, down in this case, I keep the title for that. And if I go across, I'll keep the title for that. So that's just a quick little quality of life aspect that I enjoy. Developer, not really useful for basic Excel. That's more if you're into your programming and coding. And then, as I mentioned, QTools and QTools Plus and Bluebeam are extra add-ons. So these are things I won't go through, but they're quite handy to have. Yeah, so that's the basic gist of it for Excel. So what I will do now is I will share our problems that we're going to be working with today. So I'll give it to you guys so you can have it available. Put that in chat. Okay, so if you click that link, you're going to get taken to a Word document, which is essentially what we're going to be working with today. So that's the data we'll be working from. So I won't go back to the PowerPoint slides because it essentially says the same things, but that's the data set we're going to be using. So we'll work on question 1 for now, and then question 2 is more an in your own time kind of thing if you guys wanted to. So hopefully that's okay with everyone. And if you wanted to follow along, that would be good for you too. So for the first one, what we've got is we've got a series of cars. So we've got car types being Fiat, Ford, BMW, Mercedes, Vauxhall, Nissan. And then we've got cars that are purchased by males and females. So that's just split. So the first thing we need to do is actually import our data into Excel. So from Word or from PowerPoint, because they're all part of the same Microsoft suite, we can just simply copy a table and paste it in Excel and it'll appear there. So we can just highlight our table, get to Excel and paste it. So that's what I've done here. So hopefully no one has any troubles with that. So Excel is really useful for using previous formulas or previous knowledge to influence future actions, and that's why it's quite good at synthesizing data, which we'll go through now to figure out. So firstly, on that Word document, has anyone got any issues accessing that first before we can? Is it okay for everyone? All good? Cool. So I assume it's okay for everyone. So the first thing that we want to do is, if we read the question, it says, using Excel, determine the total number of males and females making purchases from this survey. Then create a graph, a column graph showing the percentage of each car type being purchased by males and females. Label each axis appropriately. So it's asking us to do a few things here. So firstly, we need to determine the total number of males and females making purchases from this survey, then creating a column graph. So in Excel, what we're going to do, because we need totals, is to just make a new row. So we're going to click on this one here, the one below, just so it's neat. And we're going to write total. So now we need to figure out what's the total number of males and females making those purchases. So the first thing we're going to do is in our Excel formula here, we're going to press equal and we're going to use sum. So what we want to do is to sum the total number of male purchases and female purchases. So I'll just highlight the data set and then I'm going to press enter. So we can see here that what Excel has done is taken the summation of the numbers in each column and provided us with an output. Now we can do the same for the females. We can just type equal sum and then do the same thing there. But that's a little bit of a time waster. And what we want to do is try and streamline this as much as possible. So what I'm going to do here instead is, if you click on the previous formula, see there's this little square on the bottom of each cell. So anytime you click a cell, you get that little square. When we click on that, so you'll see a little plus will come up when we do that, and drag across, it takes the same formula, but it moves it across one space. And that's what I mean by Excel's really good at shifting over our data sets and using it in a way that is, I guess, as user-friendly as possible. So what we've managed to do there is to take our data and then find the summation of it without having to have manually typed in our formula again. So if we look back at our question on the sheet, it said, determine the total number of males and females. So we've done that now. We've split it up and we've found how many are taking the survey. But then it asks us to create a column graph showing the percentage of each car type being purchased by males and females. So we don't have this as a percentage. We only have this as a number. So we're not exactly answering what the question wants there. So it's a little bit limited. So now what we have to do is figure out what's the percentage for males and females. And there's a couple ways we can do this. So I'm going to go here and I'm going to say percent male and then percent female here. Now, if we want to figure out what percentage of males in total are buying Fiats versus females, we need to know what is the total number of purchases. So yet again, we have to do another summation. So here I'm going to say I'm going to insert another column because I want to have a gap. I'm going to say total car purchases. And we want to sum every row in this case. So to do this, we again go equal sum, and we can highlight that. Now, there's another way or another instrument we have available to us that we can use. So we can either drag down or drag across like we did here for this one. But because it has a fixed limit, we can also simply just double click on that little cross. So I'm going to shorten that back up again. So for those of you who missed it, if we have a data set and we've got a formula in one row like that, we can double click on that little box at the bottom and it'll take us through all our data sets. So wherever it senses that there's data, it'll click it and it'll give us the appropriate formula for it. So now we have the total cars purchased for males and females. We can actually start to see what's the percentage of males and females that are purchasing each individual car. So to do this, we rely on percentages as well as the division of the individual purchase with respect to the total. So for each male and female. So what we're going to do here now is, if we want to figure out how much or what the percentage of males making purchases are, we need to know what's the proportion against the total. So we're going to divide here. So 3 males out of 30 purchased a Fiat. So what we can do here is, if we go 3 equals 3, so we click on the cell, divide it by our total, we get 0.1, but that's not a percentage for starters. So we need to figure out how to make that percentage. And there's a couple ways. So you can start to use brackets in Excel. So we do that division and then times 100, and then we've got it there. So 3 out of 30 is 10%. Makes sense. Alternatively, though, with as minimal formulas as possible, which is what we're after, we can click on the cell, or in this case, I'm going to click on this range of cells. This is where we can start to use our number. So I'm going to click this percentage thing because I'm going to convert whatever numbers are in these columns into a percent. And now it automatically does that for us without changing the formula. So now you'd expect that I could just drag this along and we'd get the female one, right? But it gives us this little error here. So now we need to figure out, why do we have this error? And if we look at our formula, we see, okay, we've got the female purchases, that's right. But now it's dividing it by nothing. So we must have done something wrong. And what we've done wrong here is that as we've moved it across, it's moved both the blue, so the 3 here, and this little peach colored one across. So obviously it doesn't match. What we can do is lock cells. So this is something that's really useful when you're dragging across big data sets. So locking a cell essentially will allow you to drag data but not change the position of that particular cell. So in this case, what you can do is press F4. So it might be FN F4 for some of you, but F4 typically. So now when I press F4, you see I get 2 dollar signs. And the dollar sign in Excel means you've locked it. So this is saying we've locked the D column so it won't move away from D, and we've locked the number column so it won't move. Now, this is problematic in this instance because if we move that across, it's fine here, but then when we move it down, it's still referring to the 30. So if we were trying to get the data for different cars, that's not correct. So we need to figure out a way now to make it so that we can lock the cells, but not actually lock the formula. So we want it to be locked in the D column, but not locked for numbers because we want it to follow down. So we can press F4 again, and it locks it now only for the numbers, and then a third time, and now it's locked it for the column. So now if I press enter, I move it across, and if I were to move it down, these values are correct. But I wanted to just go a little bit further here and just say that if we've got, 2 columns like that, we can still double click. Well, we can't double click in this case because we have nothing there, but we can just drag down and we get the rest of our formulas. So it fills in every part of our working workbook. So we've done that aspect of it now. So the question said showing the percentage of car type being purchased by males and females, but now we have to make a column graph of it. So this is where we start to get into the data presentation type of thing. So the easiest way that I tend to do it is I go insert, I find what graph I want. So in this case, we want 2D column, and then it gives you this little blank canvas here. So this is essentially what we're going to start with to make our data that we can present. So now what we want to do is right click, select our data, and then we can add a legend series. So in Excel, you can obviously add the series name. So this is useful for annotating the graph so you have a proper legend. So in this case, we'll go male. We'll do the male one first. And now the series values. So the series values for this are those percentages. So now we press OK and we press OK. But you'll see here, it's missing one key aspect of it in the fact that we don't know what car corresponds to which. So the issue with that is obviously that we don't know what our data is corresponding with. So that presents a problem when we're trying to show our data. So if we go back to selecting our data, we have to edit our horizontal category too. So we click edit, and now we can click on those. And we've got our data nicely shown there. So now we've got the percentage of males that are purchasing each car. I guess the main thing I want to note here, though, is that there's a few things that might not be great with this. So firstly, normally in STEM subjects, we don't have our title of our charts above. So I'm going to delete that. Normally, we write things below and we refer to them as a figure. So in this case, I'm going to call this figure 1. And the way you should present data in reports, in papers, is in a manner that is clear and easy to understand without being too in-depth. So when we're writing our caption, or in this case, our figure, which has to be below, we want to say what our data is actually saying in a way that's easy to understand. Now, we haven't completed the actual graph yet, so I'm not going to write that in yet. But I just wanted to make a note as to why we delete that little title on top. So we've got our data for males. Now we'll do the same thing for females. So we'll go select data. We'll add in. We'll go series name. Call it percent females. And then our values. These are our values. And now we press OK. So we don't have that issue anymore as to what we had last time where it presented numbers because it's kept the same formatting from previously. So we don't have to change anything now. But now we've got an issue where we don't know which is males, which is females. So we've got a range of data there, but we don't know what's corresponding to what. So what we're going to do now is add in a legend. So there's a couple ways, again, you can do this. So you can click on the graph, and then you can go to chart design. And what I like to do is go add chart element, and we go to legend. So this is not particularly important. You can kind of put whatever one you want because you can move it later. So I'll put it on the right for now. I don't really like it there though because it kind of squishes our chart. So what I'm going to do is click on it, move it across here, and then I'm going to extend back our chart. There we go. So this is a lot more clear and easier to understand. But we don't know what our axes are actually telling us. So in this instance, it's pretty self-explanatory. We know that Fiat, Ford, BMW, they're cars, and we know that percentages refer to the percentage of something. Difficult. But with other bigger or more complicated data sets, it might be a little trickier to identify what's actually meant by each axis or what the data is telling us. So we can also use this to add axis titles. So again, we'll go to chart design, add chart element, axis titles. So we want a primary horizontal, and we want to add in a primary vertical. So they overlap a bit, so we're going to move our chart in a little bit, and then we're going to give it a title. So for the x-axis, we're going to call it car type, and I like to make it in bold normally so it distinguishes it. And then here we're going to say percentage of purchase. So that'll just tell us that what's the percent that males and females are purchasing. So now we've got our full chart. There's a few extra things you can do. I don't really like having grid lines there, so I'll normally delete them. They can be helpful sometimes for identifying what the true value is of something, but I think it just tends to look a bit messier, and typically you'll find in peer-reviewed papers, in journal articles, they don't tend to have them there. So we've got a nice, I guess, base graph here. You can play around with the colors. So if you click on each cell and then double click, this little menu comes up, which is your formatting of data series. So you can go to the bucket here and change the fill. So you can change the color of each. So we might pick, say, a light orange. Light orange is a nicer color. And then we'll go to this one and we'll pick another color. Let's go light blue. So you can start to play around and have a look with what you think looks better. By default, one thing I dislike significantly with Excel is the fact that it has this little gray border that you'll see around graphs. So again, double click, and then we can go to border, no line, because now you don't have it. So now when you present it in a Word document, it won't have that little border around it. In my opinion, it just looks quite messy. And there's other things you can do. So one thing I'll do is I'll click on my little axis here, and I want to change the color, not of that, of the line. So to make it a distinguishing line between the axis and the actual data. And then I want to do the same on this one, but this one doesn't have one. So I'm just going to add one in, a black line. There we go. So now we have a bit of a distinguishing aspect of it. Another thing you can do is add tick marks. So tick marks are really useful for identifying when a new data set begins. So I'll put one there, and then I'll click on this. And again, I'll go to marks, and we want the major ones on the outside. So now we've got a bit more of a presentable data set. Now we need to title it. So the key aspect of figures and titles in Excel data sets or anything when you're trying to present is to make sure that it gets the message across and it's really clear and concise. So in this case, we have a graph which is showing us the different car types that are purchased by males and females. So a title that we could have is comparison of purchasing choices of cars by males versus females. And this data set now tells us everything we need to know. So we're comparing the purchasing choices in terms of percent made by males versus females for different car types. Now that's ready for us to put into a document. Now, this figure that I've got here, you probably wouldn't copy paste it like that. The only reason I've done it here is just to show you that it goes below, but typically you won't write your figure titles below what your graph is in Excel. You'll typically just make the graph, copy it to a Word document, and type that below. Alternatively, on Word, there is a thing that I don't think Excel has. No. So you can right click and then it says give it a caption. So you can actually do that alternatively. So if we go back to that question now and that word that I've given you all, we've determined the total number of males and females making purchases. We've created a column graph showing the percentage of each car type being purchased, and we've labeled each graph, each axis appropriately. But now, if we look below, the dealership wants to do some additional statistics with it. It wants to know about probabilities that different genders would have in purchasing a different type of car. So now this requires some knowledge that's a bit extra to what we typically, what this course is for. So this is talking about probabilities. So I've mentioned there that in probability, we know that when things say and, we refer to a multiplication probability, while or is an addition in terms of probability. So Our first question is, what is the probability that a male making a purchase would buy a fiat? So this one's pretty easy to grasp. So when it's asking the probability that a male would purchase a fiat, it's saying that what's the probability that firstly the person is male, and secondly that the person is female. And secondly that the person is buying a fiat. So the first thing we need to do for that is actually figure out the total number of people who are actually purchasing, because then we can figure out what's the probability that they're male or female. So we've got our two totals here for these two columns. Excel's really cool in the sense that we can even do formulas that are attracted to other formulas. So in this case here, these two cells have these formulas, these summation formulas. We can also put a thing here that sums these two for us. So here I want equals sum, and I want these two columns summed. So this is the total number of participants that we've got. So that tells us how many people have purchased a car in total in this study. Now, what we want to do now is to figure out, as the question asks, what's the probability that it's a male and that they would buy a fiat? So firstly, what we need to do is find the probability that they're male. So the probability that they're male is 78 out of 159, because that's what we found. So for our first criteria, we'll do that. We'll just equal 78 divided by 159. So the probability that they're a male is 0.49, which makes sense. So about half the population is male, half is female. So it makes sense that half the people buying a car are male and half are female. So that's good. But now we need to figure out what's the probability that they would also buy a fiat. So the probability that someone is buying a fiat is 30 out of our total 159, because that's the number of purchases that are made. So if we go here and we go 30 out of 159, we can see we've got 0.1886. So that's about 18%. So it's saying that we've got 18% of people who are purchasing a fiat, but about half the percent of the population is purchasing the fiat. We can see that, okay, to figure out how much is the probability that is a male purchasing a fiat, we can just multiply these two together. And I say multiply because we need to find what's the probability that they're male and purchasing a fiat. So again, in probability, when we have AND statements, we multiply them. So we can go down here and we can say it's equal to that multiplied. So in Excel, the little asterisk key is your multiplication. So that times that. So the probability is 0.09%. So it's quite low. 0.09. So it's quite low. If we put this as a percent, we've got 9%. So about 1 in 10. Now, that's a lot of cells that I've used for that. So it's quite messy, really. We can do this and sort it in a way that's more efficient. So we know that we can have the probability that they are male. So we can use brackets, that divided by that. And then we know we have to multiply it by the probability that it's someone purchasing a car. So that divided by that. So we can do it. Ooh, what have I done? Have I changed something? All right. Yeah, so we can do it all in one cell by just combining the two functions. So we need the B9, D9 one. So we open up a bracket. So that divided by that. So that's our first function. Why is that changed? Oh, because I put the wrong one. That should be there. There we go. And then we can multiply this by our second one, which was the probability that they're male, they're purchasing a fiat. And we close our brackets. So now we look at the two data sets. So this one combines our two multiplications here, whereas this one does it all in one formula. So the point of that I wanted to show is that we can use Excel to merge formulas and make it as succinct as possible. So now instead of having to go through 3 cells that I did here, I've done the exact same thing, but in 1 cell. So now we know that this is the probability that they are male and buying a Fiat. And we can extend this out. So that's the first question done. So what's the probability that a male making a purchase would buy a Fiat? With probability, you don't necessarily have to express it as a percentage. You can express it just as a common number, 0.09, that's fine. Typically, it is expressed as a decimal. The percentage is just used to give chance, which is slightly different. So if we work on, it says, what's the probability that a female making a purchase would buy a Mercedes? So there's a couple things we can do. We can either enter the whole formula again, or we can just slightly modify what we've got here. So what I want to do here is I'm going to drag that formula down. Obviously, it's wrong now because everything has moved. But what I want to do is move different things so that we figure out what that proportion is going to be. So we need a female. So this one was previously male. I'm going to move it there. And our total stays the same for both. And we want to know what's the probability that they would buy a Mercedes. So we're going to move our car down to Mercedes. So what's the total number? We press enter, and then we get given our result here. So this is the probability, female and Mercedes. So without having to type everything again, just because we know where the formulas are, we could just move them straight away. So it's a lot easier for us to now go through and start to figure out the rest of the questions. So next it's asking what's the probability that a male would purchase a Ford or BMW. So if we're purchasing a Ford or BMW, it's the probability that they're a male. So we already have that. It's B9 on D9. So I'm just going to do that here, just to give us a value. So that's the probability that's a male purchasing a car. And down here, because we want to know probability that they're male and purchasing a Ford or BMW. So we need to know what's the probability of purchasing a BMW or Ford. So again, we can start to use the combination of formulas. So we're going to use here that one, because that's the probability that they're a male. We've already determined that one previously. So it's the 78 divided by 159. And then now we need to know that's the probability that they'll purchase a Ford or BMW. So we multiply that. The probability they'll purchase a Ford is going to be 25 divided by 159. Or, so in maths, or represents addition. So we'll add the probability that they'll purchase BMW. Now, just to be safe, because we're multiplying and then adding, we want to put in extra brackets here. So what I've done is just before this cell here, and then at the end, I've put in extra brackets because that's multiplying at the end. And then we press enter, and let's put it as a percentage. So we've got a 14% chance. So just be wary. You can use as many brackets as you want, but make sure you enclose your brackets for what you're trying to actually find. So that's the main thing I wanted to get across with that. So after that, we have a female would buy a Nissan or Vauxhall. So I'm going to do something similar here. I'm going to find what's the probability of a female buying a car. So obviously it's the inverse of that. If that's 0.49, that has to be about 0.51. So here I'll write male prob, female prob. And I'm going to drag this down. And this is the probability female, what was it? Buying a Nissan or Vauxhall. Nissan or Vauxhall. So this is obviously wrong because I've dragged it down and haven't locked any cells, but we're going to use it and move things. So we want a female, so I'm going to move this to female here. And then we want the probability that they're buying and Nissan. So we'll move 1 to Nissan and 1 to Vauxhall. Enter, we've got 19%. Again, you can switch back by putting the comma or the percentage sign. So the final question we've got here before we wrap it up is, what is the probability that 2 females would purchase a Fiat and Mercedes in succession? So this is just saying that we have to have this probability, so the probability of 1 female, times the probability of having another one, so 0.5 times 0.5, and then that they are purchasing a Fiat or Mercedes. So the only difference to this one, so I'll just copy paste it there and move it down. The only difference we've gotten there is that we have to account for the fact that there's 2 of them. So in our formula here where we've got E11, which is that, we just have to multiply it twice. So I'll do it here. I just add it there. And then that shrinks our percentage. So that's because in probability, when we've got 2, it shrinks and shortens how many we can have in succession. So it's more unlikely to have 2 females in succession than it would be to have a male and female. So that was a bit of a run through there of some of the, I guess, things we can do with Excel. I know probability is not everyone's favorite topic, which is why I pretty much chose it. So hopefully it wasn't too bad, and with the recording it'll be a lot easier to follow. But I wanted to point out that the main thing is that we can use the different functions of Excel regardless of what we're actually applying. So it doesn't matter if it's probability, it doesn't matter if it's algebra, it doesn't matter what our actual topic is. And it's used a lot, not just in math, but in all of STEM subjects. So I use it in engineering and water quality. I have friends who do a lot of data management for, I guess, city planning. So there's a lot of different aspects that we can use Excel for. Unfortunately, we don't have time to cover all of them, but I did want to give that, I guess, brief rundown. So I'll go back to my slides now. So this is the problem when it loads. That's the problem that we've just completed. So we've gone through and solved all of that, and we've entered our data. If you look below, you've got an additional problem there, which is talking about cars and not cars, company revenue. So how much money a company is making over a 1-year period, and there's 5 different companies there. So what you have to do with this data set is to create a line graph that shows each company's performance. So essentially our x-axis will be our months, and then our y-axis is going to be how much is earned per company. And then it asks you to determine the average earning of each, as well as the average revenue each month. So this is where you start to add a few different formulas. So if we look up AVE, this one just types it. So we want to use average for this one, which very similar to the sum, just requires an input of numbers. So that's what you'll be using for that data set. It's just the data of each company and then what the average earning is for each month. So I'll let you guys play with that one in your own time. If you do have any questions with it or anything's not working, do feel free to reach out and I'd be happy to help with that. But I just wanted to introduce you to that and to have an idea of how that would work. So wrapping up now, since it is nearly 10 to, I guess I wanted to show you guys an introduction of why Excel is a powerful tool and why it's used in industry. So Excel is often compared to programs like MATLAB in terms of what it can do. MATLAB is more programming based though. The issue is that Excel provides us with free, well, free if you're a student, or a cheaper version of what you can do with MATLAB. But if you are experienced with Excel, you can do pretty much all of the same functionality or same inputs that you get out of MATLAB, only it's about 10 or 15 times cheaper. So I've shown you a very rudimentary or very introductory, I guess, data set, and I've presented that for you guys. So the main aim was to show what we could do with that data and how it's useful in that sort of environment. So for us, having that data set and being able to present it is a really vital aspect of Excel and what we can do with it. So the content covered, as I mentioned, the content covered today is pretty introductory. It covered a lot of the basics, and we use that to get a bit of a grasp of why we can apply Excel and how we can use it. So it's useful for really small data sets like what we had today, but you can also apply it to really big ones as well. So in your STEM degrees, Excel will be vital for your thesis if you're doing engineering or if you're doing honors. It's really useful as a way to synthesize your data. So understanding not only what to do with it or how to present it, but how to process that data is really important. So I do a lot of work with statistics for the PASS program. And it's not only about having the data and looking at what it does, but it's also about trying to find trends or to find key information that we can use that data for. So it's not just a series of numbers that are just presented in a table. So there is an endless scope with Excel. It is a very powerful instrument. As I mentioned before, it can do almost anything that you'll actually need to have it for. It'll be able to do it. Google is your best friend with Excel. If you don't know something, it is very easy to Google how to find it, what formula to apply. I use it all the time. I'm still learning with Excel even as I go. So I feel like it's a never-ending, I guess, learning experience. And finally, one thing that's probably more relatable for you guys is more and more employers are looking for graduates with a strong base level of Excel. So most companies do rely on data analysis nowadays. It's important as we shift to a more technology-based society. So more employers are keen on having people who are graduates with strong Excel skills. They don't have to be proficient in Excel, but they want people who are able to know how to figure out what it can do and what its importance is. Yes, that's the main things I wanted you to take away. So finally, that's the end of our workshop. So I did want to thank you guys for coming. We will send out the recording over the next couple of days. So if you missed anything, feel free to check that. Before you go, please do that survey. So it will really help us to figure out what it is you're after. I'm in a meeting, just 5 minutes.
Yeah,
so
right?
that link will help me to get feedback on the program, and then it'll allow me to make these sessions much more interactive and helpful for you guys. So please go through that and do that little survey. It'll take about a minute. It would be greatly appreciated. And if you have any questions, do send me an email there. Other than that, thank you guys, and I will hopefully see you at the next workshop in week 7.